My name is Fredrik HEINTZ. I'm a professor of computer science at Linköping University in Sweden, and I'm also the coordinator of one of these 4 original ICT 48 networks called TAILOR, which is what I will be presenting here today. Yes. So basically, what we really want to do, the overarching vision of TAILOR is really that we want to develop the scientific foundations for trustworthy AI. So, I mean, Europe has taken a very clear stance, and I mean, of course, the whole Confiance.ai initiative is very much focused on this, that we in Europe, we want AI, but we don't want any AI, but rather we want this AI that we can actually trust and be sure that we have safe and reliable applications and systems. And so we want to develop these scientific foundations for this. And we also strongly believe that in order to actually achieve this, we will need to combine techniques coming from learning, optimization, and reasoning. So we don't believe that there will be a single particular technique that will be able to solve everything, but rather that we need systematic and well thought through ways of combining and integrating these different techniques that all have their strengths and weaknesses. And of course, the end goal of this is that we want to help Europe in realizing this European vision of human-centered, trustworthy AI. So the TAILOR consortium is quite large. We have 54 partners from 20 different countries. We have 6 partners from France, including INRIA and IRT and CA and a few others, EDF. We also have what we call network partners, so it's actually possible for other organizations and research labs to be a member of this network. So if you're interested, please get in touch. We also have 10 industry partners. So what we selected to do here was that rather than to have a kind of a broad coverage, I mean, we're already quite a large number of partners, but rather we want to work with a few selected companies, big companies like ABB, EDF, Volkswagen and so on, where they can act as kind of a representative for larger industry sectors, so that we make sure that we have the connection to industry, which of course is very important. And I should also say that we have had great support from Claire. The Claire network has been kind of instrumental in setting up TAILOR, and we hope also that it will help us to live beyond the time of this project, which is expected to end in 2 years. So we have, of course, a number of objectives and what we want to achieve. So first of all, of course, we want to establish this network, this pan-European network on research excellence in this area. We also want to define and maintain a research agenda, strategic research agenda. Actually, that work is partly led from INRIA. Mark Schönauer is very much involved in that. I would say more about that later. And the purpose of this network is really to create the capacity and the critical mass to actually develop these scientific foundations for trustworthy AI. And of course, we want to build collaboration with industry and academia and so on. And that's part why I'm here today, to build on these collaborations. And of course, we also want to progress the scientific development in this field. So I would talk more about some specific research results coming out of TAILOR. And we also want to engage with the general public. So as I said, I think that the main purpose of these networks is really how can we organize ourselves in order to be able to boost the capacity to tackle these major scientific challenges. So the way that we have organized ourselves is that we have a core network of outstanding AI research centers, as well as these major European companies. And then we have a mechanism for extending the network, as I said, with these network members, which is open to everyone that's interested. We also have a special fund called the Connectivity Fund, which allows us to provide third-party funding for those that want to do joint visits or workshops and so on. I would, again, talk more about that later. We have then 5 virtual research environments, which are these where we actually do this scientific work. So that's the point, to be able to address larger problems that any individual research group can do. We also have a special area where we're actually working with AI-based network collaboration tools. So we are also experimenting about how can we use AI to simplify and help us in doing our everyday work. So we have Peter Flack from University of Bristol is leading this today, for example, developing techniques so that you can have one source and then generate both your code and your papers and your presentations and so on, so that you don't need to have this kind of multiple parallel kind of versions of your work. We are also working on this strategic research and innovation roadmap, so really defining where do we want to go and why do we want to go there. And preferably even also how to reach that, so that we want to drive this long-term scientific vision that we have of developing these scientific foundations for trustworthy AI. We also have what we call more bottom-up coordinated actions. So actually, this is an idea we took from another one of these networks, the Humane AI Net, that had introduced this, which we think was a good idea. And of course, we think that good ideas should be promoted. So therefore, we have been using that as well. So where a small number of partners can get together on a specific topic, do the research, write a paper, and then make progress in this particular area. So together, we think we have quite good forms and kind of the means and structure for progressing and addressing these major scientific challenges. So one of the things that we published, so we published this Strategic Research and Innovation Roadmap in April this year. And now we're working on this to expand and improve it. So in this roadmap, we have started to highlight some of the major scientific and innovation challenges related to trustworthy AI. And one of the things that we have identified is really is how do we measure these different dimensions of trustworthy AI? That is a really major challenge. How do we quantify and how do we compare different approaches, including defining benchmarks? As I mean, the previous speaker was also mentioning this. We really need to be able to compare and compare different approaches so that we faster can make progress in this area. At the same time, of course, we don't want these benchmarks and data sets and so on to be limited so that we become overfitting to these particulars, but actually really pushing the research. We have also identified this need to find more systematic ways, of course, to integrate different approaches. I mean, different paradigms like probabilistic, neural-based, and logic-based, and so on, and a few others. So you can look at the roadmap on our webpage. I mean, the full link URL is kind of long, but if you go to the TAILOR Network page, you will easily find it there. And there is also a short version, just 2 pages, to quickly get an overview of this. And this is work that we will continue. And as I said, Mark Schönauer from INRIA has been one of the leaders behind this roadmap. So if you want to provide input, he's close by. His office is right next here. So then we have the research program. So our research program has 5 different areas, as I said, 5 research environments. So the first, of course, is in trustworthy AI. So this is really one of these horizontal challenges where we are looking at how to really address actually these different dimensions of trustworthy AI. The second of these horizontal research areas is about integrating and combining different paradigms and representations. So this is led by Luc Derat from KU Leuven. And then we have 3 more verticals. So the first one is around acting, so how to do reasoning and learning for acting, so making decisions of different types, for example, planning, reinforcement learning, and so on. And this is led by Giuseppe Di Giacomo from La Sapienza. The second one is on social AI, so this is all about how can we get these systems to interact with people, but also with other AI systems, so multi-agent systems and so on. And this work is led by Anna Paiva from Lisbon. We have the final work package on auto AI, so we see today that there is a lot of interest in auto ML. So basically, how can we automate the processes of setting up and running these quite sophisticated tool chains and pipelines and so on that we need in order to really build machine learning-based applications that today, I mean, it requires a lot of deep technical knowledge and a lot of manual labor in order to achieve it. So the question is, of course, can we automate this, or how much of this can we automate, and thereby making these tools and methods more easily available to a broader community? And of course, here we want to expand this not only for machine learning, but for AI in general. And this work is led by Holger Huus, who's currently at Aachen University. If we then go into these a bit more detail, so when it comes to this trustworthy AI, the TAILOR perspective, it's really actually we have started with this perspective that was provided by the high-level expert group on AI, where myself and Philip Susarek, who is also here in the audience somewhere, we were members of this, and there we defined this different 7 dimensions of trustworthy AI. So these are the dimensions along which we are doing the research here. And one of the results that we have so far is that we have done a survey of explainable AI systems. For example, doing benchmarking of different methods for this kind of how to take these black box models and make them more explainable. Looking at dimensions such as what kind of input has been used. So, of course, we see a lot of tabular images, but also text today that require different methods and different solutions. And what kind of explanations have been considered? Because, of course, we know that what actually can count as an explanation is a very broad concept. And personally, I believe that explainable AI is basically an AI complete problem. In order to solve explainable AI, we will have to solve all of AI. But of course, there is a lot of things we can do on the way towards that. And here we are looking at different things like salience maps and prototypes and counterfactuals and so on. And I looked a bit at the posters, and I saw some posters looking at, for example, these prototype-based approaches towards explainability. So I think this is one good place to start if you want to know what's going on. Another very good place to look at is that we have published a handbook of trustworthy AI, where we are trying to, for each of these dimensions of trustworthy AI, provide a brief summary. What is it? What is the kind of motivation and background, but also what are some of the guidelines and softwares and concepts and key references related to that. So we hope that this will be a useful tool and reference for the community. So, and if you have comments and suggestions, please get in touch. We are always looking for how to improve this, so feedback is welcome. And when it comes to this integration of different approaches, I'm sure you have heard this before, but we seem to see that we have these different types of also human ways of approaching thinking or making decisions, where the kind of traditional approach, especially if you come from a more classical AI background, has really been this system 2, where we have this explicit, deliberate, and very explicit and introspective, often logic-based way of making decisions, which actually I would say is the kind of prototypical analytical way of approaching problems, which of course is things that we normally do most of our days at work. Is we do this kind of analytical work where we work explicitly with formulating and solving different types of problems, and then showing that we actually have solved them. And I would say that the kind of classical AI approach has been very successful in trying to mechanize and understand this type of reasoning and this type of decision making. We see a lot of good things there. But we also have this other type of system where we call it the system 1, the fast system, which is then more unconscious, automatic, and we don't have this introspection. And the prototypical example here is intuition, where we intuitively feel what the right answer is to a question, but after thinking about it, we may realize, it maybe wasn't the right thing, but usually we don't understand how we reach these intuitive conclusions. Another example is, of course, our perception. We are extremely good in seeing and understanding things that we see around us. I mean, identifying objects, interpreting scenes, and so on. But usually, again, we have no introspection in how our perception actually works. We just see an object and we say, oh, that's my friend or my colleague or whatever, or is this type of object. We cannot explain how we actually reached that conclusion. And I would argue it's the same where we see this very successful data-driven machine learning approaches. For example, these deep neural networks, which have been extremely successful in this kind of perception-based approaches. But of course, we have the same challenge there that, yes, they often work, but sometimes they make mistakes. And it's difficult for us to understand exactly why they made these decisions or how to reach those conclusions. But of course, from a mathematical point of view, they're extremely well defined. A neural network is just a mathematical function, so we can explain exactly how it works mathematically, but that does not make it explainable in our world, because we're really terrible at these multi-million dimensional spaces and how to look at hyperplanes in these multi-million dimensions, unfortunately. But of course, what we want to do is to combine these two different approaches so we can get the best of both. Can we get this kind of adaptivity, and we don't need to do all the detailed programming and fill in all the specifics that we can instead use machine learning, but still get the guarantees and this a better understanding of how decisions were made through more reasoning-based approaches, for example. So this is what we want to do, combining these. And a bit more technical or a bit more specific is that we are both interesting, I mean, because often these data-driven machine learning approaches are very successful in the perception space, but when it comes to more this reasoning, planning, making different types of more long-term decisions and so on, usually these reasoning-based approaches are superior. So of course we want to connect and combine these. We also want to connect different approaches from neural-based approaches, probability-based approaches, logical-based approaches. And so actually we have these 7 dimensions for integration of these. And if you're interested, there is a paper from ICHCAI 2020 on that. And to give 2 concrete examples, so these are examples both in the discriminative space. So there is a system called Deep Problem that's been developed by Keir Leuven, Luc de Rat and colleagues there. So of course, previously they could do this kind of neural network-based learning, use that as input to this more logic programming, probabilistic logic programming-based approaches. But what they've been doing is to integrate this more directly into the probabilistic logic framework so that you can actually use these probabilistic logical rules to constrain the learning so that the learning converges faster. And at the same time, you can do this logical reasoning, probabilistic logical reasoning on top of these classifiers that you have learned through deep learning, for example. And very recently, actually, it's been accepted to NeurIPS 2022. They've also looked in how to do that in a variation autoencoder framework, where they basically have the encoder, but then the output of the encoder is divided into 2 parts, one sub-symbolic part and one symbolic part. And then they feed the symbolic part into a probabilistic logic programming and using that to compute a posterior, and then they combine that with this sub-symbolic posterior, and then they do the decoding based on that so that they can get this benefit of this learning. And one of the benefits of learning is really, the reasoning part is that you can learn to understand, or to rather than to look at the instances, you can look at classes. So you have better capability of transferring to new domains and new problems. So that was this about integration. When it comes to acting and reasoning and learning for acting, one area that we're very much interested in, how can we push reinforcement learning from the current Markovian domain, where you're basically only looking at the current state, you don't care about the history, to a non-Markovian domains where we can actually take the history into consideration and having more flexibility in both generating plans, but also taking account of what has happened. So instead of learning this simple state to action functions, we are instead learning automata. so that automata can maintain the state, and depending on what state you're in, you make different decisions. So of course this has a much more structure and much more, let's say, flexibility in doing this. So that's ongoing research within this area. And actually we have several Best Papers Award, both at ICHCAI and ICAPS, related to also how to use learning to learn the planning domains over which you do the more symbolic planning as usual. We also have interesting work where we're kind of touching between this planning and the more social or interactive part. So this is work done at IRIT in Toulouse, where they're looking at, so in some sense, if you want to take other agents into consideration, you really need a theory of mind so that you can understand or at least reason about how other entities, agents, and so on, what are they thinking and what are they believing and so on, and taking this into account when you actually do the planning and when you do the interpretation of what they are doing. For example, I mean, if they say something that's false, it could just be that they just don't know the answer, but it could also be that they're actually actively trying to deceive you, which of course would gather a very different kind of response from you, depending on which of these two alternatives you believe is the correct one. So here they have been developing planning techniques which takes this epistemic information into account, so that you can actually plan based on what the agent believes that other agents believes, and so on. And a second example from this social AI work package, or this area, is about a concrete example where you can use agent-based modeling, which is one of the things that we're working with in this multi-agent systems, to actually model complex situations. For example, in this case, people from Delft University, Neil York Smith and colleagues, they have been working with an agent-based simulation of the what do you call it? Accommodation market in Amsterdam. So basically the policy question is, how should we deal with companies like Airbnb and others that are helping people to rent out their apartments? What are the effects of these kind of rental of services on the housing market? And actually through this simulation they could show that if you don't regulate it, or rather if you regulate this, you can keep people with lower incomes to keep on living in the city centers. You have less, the prices of the housing doesn't go up as much as it does if you have this opportunity to make money from renting out your apartment rather than actually living there. So I think this is a very interesting example where we can use this kind of agent-based modeling to help policymakers make more informed choices when they design their policies to govern the way we work and live. So the last area is auto AI. So here we have been doing research on, for example, automated algorithm configuration and portfolio construction. So here we have achieved substantial improvements over state-of-the-art methods. I really think this is interesting because we see today there's a lot of work in this kind of hyperparameter tuning and so on, and this is taking this one step further, not only keeping like one particular instance, but actually have a portfolio of different approaches to cover more cases. Another example is that we're working on benchmarking multi-label classifiers. So in order to really push this area of auto AI, we need good benchmarks because we need good ways of evaluating these different alternatives. And therefore, we have developed this benchmark on multi-label classification, which is the largest existing such study to date. So that was a kind of a summary, or not a summary, but some examples. I mean, of course, we have 54 different partners and like 400 people or so. No, maybe it's a bit too much, but several hundred people involved in this network. So it's a lot of things is happening all the time. But these were some of the highlights. And I really think moving forward, what we see is a number of trends. So first trend is that we want to move away from these purely correlation-based approaches towards more causality-based approaches. So I think this is one of these major areas going forward. And of course, we want to be able to combine more data-driven and more knowledge-based approaches in a structured and systematic way. We want to then use these models both to explain what we have observed in the past or things that have happened, but also to use this to predict what is likely to happen in the future. And I think this kind of summarizes a lot of the general trends in the area. So before towards this end, I also want to mention this industry collaboration, which we think is very important. And this work package here is led by Philip Susag, who is also here in the audience. So if we have more specific questions, you can reach out to him as well. But we're really working very systematically with how to engage industry. And one of the major things we're working with is what we call theme development workshop, where we have some specific topics. For example, the future of mobility was one of them that we had, where we collected key industry players and key researchers in this area, and together they discuss and try to come up with what are the roadmap, what are the challenges for achieving success in these areas. We're also looking into this, how can we build up this industrial academic co-innovation transfer labs, so really having a closer collaboration between industry and academia. That's something we really want to push further, and many more things. So here is just an overview of those theme development workshops that we have been running, both on future mobility, as I said, future of healthcare, future manufacturing, and also the mitigation of bias and disinformation, which was a joint theme development workshop with two of the other ICT48 networks. And from these, there are reports, so if you're interested, you can read about it. And I mentioned in the beginning that we really want to involve the European community at large. We therefore have set up what we call the TAILOR Connectivity Fund, which is an opportunity for non-TAILOR partners to do joint work together with TAILOR partners. And of course, the goal here is to build excellence. We want to support scientific step up. We want to support scientific influx, and of course, new scientific alliances. And what we aim for is to have about 100 visits and workshops. Of course, due to pandemic, we are a little bit behind on the schedule. But of course, the positive note is that there is significant funds available, still available. So if you're interested, we have 3 calls per year. And the next call closes in November, is mid-November. And you can apply to do, for example, a research visit to a TAILOR partner, or you can invite some TAILOR partner coming to your organization. You can also apply to do some joint workshops. And this funding can only cover travel and sustenance, so we cannot cover salaries, but at least we can help you getting connected. So this kind of concludes my presentation. And I really think what's interesting is that we want to, the TAILOR network, the goal here is really to bring together the leading researchers and research organizations in these areas of learning, optimization, and reasoning, together with leading European companies to develop these scientific foundations for trustworthy AI. We have a number of major instruments to achieve this. Of course, this research innovation roadmap. We have this basic research program. We have the connectivity fund. We have this network collaboration. So actually, we had our first physical event in Prague a few weeks ago, where we met for the first time after 2 years. And it's very nice to be back in person and meet people and to have this kind of discussions and really progressing science. So also, I want to say, actually, I realized I had one more thing here. And that was, of course, I mean, TAILOR is one network, but I think if you are a company or if you're an organization and really want to push this trustworthy AI, I think there are several things that you need. And it's, for example, first of all, we need to realize that it's not a question of either humans or AI, but it's rather how can we combine AI and humans together. That's why we have this human-centered perspective. But we also need to work much more in education, so I think that's an area where there has been significant more work needed. Of course, the TAILOR network has some educational activities, but that's not our main focus. Our main focus is more on the research side. And we need to build these ecosystems. And I think here it's very nice to see this Confiance AI where it seems like you have a very strong network where different organizations and companies meet, share, and really learn together. And of course, TAILOR wants to be part and support those kind of ecosystems. So with that, I would like to thank you very much and hope that you want to also work together with us in TAILOR and that we can provide value to you because we really want to develop these scientific foundations for trustworthy AI and really realize this European vision of human-centered trustworthy AI. Thank you very much.
Thank you, Fredrik. I hope that some of our partners in Confiance.ai will look at the interest of your connectivity funds and try to organize a few things. We have time for questions, and as before, I'm going to ask you the first one. You know, last year, when we had our first annual meeting in Toulouse, we had an invited talk by Yoshua Bengio. Remotely, he was in Montreal. And he was also advocating somehow for causal reasoning instead of correlation. Well, we all know this question, huh? And I asked him, okay, but how feasible it is? Because we know that it's important, but we know that it's very difficult. At that time, 1 year ago, he was saying that he was able to find causality in, let's say, a few tens of variables, which is already much more than what I thought myself. So what do you think would be, do you have any perspective on this? When will we have some causal reasoning from data, let's say, because causal reasoning from other things we know. When do you think we have some thing that we can really start to use for real-world applications?
So, first of all, I would like to say that, in some sense, we are using it every day, but it's implicit. And I think that is the danger. That, any model we make or any data set we collect has all the, implicitly the causal structure, but we don't explicitly represent it or explicitly take it into account. And what we do today is more this random controlled trials in order to sort out some of these causal connections. So, of course, we are aware that it's an issue. But we're not really addressing it explicitly. So I think what will probably be the first step towards that is starting to actually represent what are the causal assumptions that I'm making in order when I, for example, collect this data set. And there are these more, say, Bayesian network kind of models where you can take this and then you can interpret the data in the light of that particular causal structure. And then you can see, does it make sense, or do I need to change the causal structure in order to get the data to kind of work out? And we see, of course, this being done in small scale already. I think the challenge is really, again, it's first of all developing the methods so that they're becoming easier to use, and then to scale them up. But I would expect them to start to be using within a few years at least.
Thank you. So I'm looking for raised hand. So do you have any question here? I don't see. Oh, you're very quiet.
Get the front row here.
Yeah.
In your talk, in your structure, I've seen some relationship to the European AI Act. Yeah. Also in the structure, how do you see the relation, and do you see something to build up structures to enable the industry and also to fulfill the requirements of the AI Act?
Yeah, so I think that's a very good and important question. What is the relation between this work and the AI Act? And I think, of course, the AI Act has its own life. It's been run by other type of people than us. But of course, what we see as our main role is, of course, to provide the technical solutions to help industry and others actually realize these goals or these regulations that most likely will come in some form. At the same time, I think we have to be open that, it's very challenging to actually be able to live up to those expectations. And there will be a requirement also to, not only from a technical perspective, but also from a more, non-technical, more social, and we have the next talk, maybe solving some of those issues. But because taking these things like fairness or equality and so on. I mean, those are concepts which are easy to say, but very difficult to actually formally define. And then it becomes a question, I mean, from a legal perspective, what's an acceptable way of defining fairness or acceptable way of kind of removing bias in your data and so on. And that, I think, will be a very challenging question to, both from a technical perspective, but then also from the legal perspective, reach some kind of joint understanding of what is sufficient in the legal term of this. I think there will also be standardization that would be needed to kind of encode these kind of best practices and so on. So we are not that much involved in standardization activities, but there are other organizations like ADRA, the AI Data and Robotics Partnership, where we want to push these standardization efforts, because I think that will also, of course, help to kind of codify best practices and so on. But it will be challenging to live up to these regulations.
Thank you.
Any other question in the audience? Yes, there is one there. So you have a micro? Well, maybe you can come.
Yes, personally, I'm convinced by the fact that intuition is part of intelligence. And I was very interested with your thinking fast topic. But how do you explain intuition? Because it's a very big deal. It's already difficult to explain something regarding the reasoning, but explaining the intuition, I don't know.
Yep, no, but I think it's a very interesting question. I mean, how do you explain intuition? I mean, maybe this is more personal than kind of scientific, but I really think intuition is probably very much dependent on experience. And actually, I think here again, we see the similarities to machine learning. I mean, in some sense, it has experienced a lot of data. And based on this experience, it identifies regular patterns or kind of co-occurrences of things. And then based on that, it does a matching. Oh, this is a situation I've seen before. And in this previous situation, it seems like this is the right thing to do, or my historical experience is that this was the right thing to do. And we do that more implicitly. So under the assumption that that's fair representation of what intuition kind of corresponds to, I think what really would make sense is, of course, what data did you train it on? What kind of training, how did you train it, and so on? How did you evaluate it? So maybe you cannot explain the particular decision itself, but by explaining how you reach this system, or how you developed or produced this system, I think you probably also can have some understanding. Okay, you train it on this kind of data, so probably it will make reasonable decisions in those kind of situations. But this particular one is outside of that. Probably the decision is less realistic and so on. So, and we see that in some sense about this prototype-based approaches, and I mean, Lime is one of those examples where it tried to look at actually looking more at the input, but trying to kind of exemplify what type of prototype or what type of class of decision or similar experiences have I seen before, and therefore kind of making the implicit argument that that's or the reasoning behind it. So I think you can do some things. Again, I think it's very unclear what we actually mean by explanation. Again, from a bit more personal perspective, I really think what we're probably going to need is more interactive systems. So just providing, oh, here's an explanation. I mean, usually that's just the first step. Then we want to ask, oh, but what about this? Or can you explain that part a bit more? And so on. So to really get this explainable system, I think we need to have an interactive system where we can follow up with more questions and to explore it. Because not only is it because that we want to kind of dive into some parts, but I also think that there are probably very, very many things that could kind of contribute towards an explanation, but not all of them are relevant to me. And instead of building a lot of kind of customized explainable systems for different types of users, I think having this kind of interaction will allow the user to steer the explanation towards things that it's relevant for them, that will make them feel that they can understand on what basis these decisions were made.
And I remind you that we have a parallel workshop on explainability this afternoon. So to dig more into this.
Up, all the way up there. No, there's one
see.
more there.
I don't see. It's too much.
Up
Okay,
the lane here.
Hello, thank you very much for your presentation. I come from IRT System X and in the mobility field, so everything related to automotive industry and automatized vehicles. My question is a little bit related to the previous one. In the previous one, we were talking about intuition. I was wondering, I wanted to get your feedback on rather the intention of other users. I think it relates to one of the packages, which was social AI maybe. I'm thinking about how culturally it is very different to be able to assume the intention of other users for the vehicle to react, and how it is a challenge to be able to formalize that scientifically, mathematically. I wonder if you have any feedback on this. Is there hope, or does it just depend on the data that we're being trained on? And can we say that we cannot just remove biases, but rather introduce the right biases for the operational domain of the vehicle? I don't know. I wanted to get your feedback on that.
So, I mean, overall, the question is basically about intent, and I think, again, this is a very important area. So, of course, we use intent when we interpret how people, or I mean, what we expect from a system. And I mean, we could take things like gaze. We are like looking at something, and that implicitly means that, oh, we want that object. We say this or that, and then we look at something, and if the autonomous system does not understand that, it will not be able to help us. So intent, and of course, if you have autonomous driving and so on, you need to understand the intent of other drivers. So actually, intent was an area where there's a lot of research, I think in the 90s and so on. So there was research on this intent recognition and so on. So basically, how do we detect what the intent is of other entities? And then there were explicit reasoning approach. I mean, for example, this belief, desire, intent, BDI architectures that was developed, I think, around 2000. No, actually, it started in the 90s, but yeah. So there was explicitly taking intent into consideration when you make decisions. So basically, intent was setting the long-term goals, and then based on your long-term goals, you decided on what are my kind of more short-term goals that I want to achieve, and so on. So, I mean, there are definitely approaches both towards intent recognition, towards using this explicitly in making decisions. And then the third, which you also touch upon, is this, I mentioned this epistemic planning. Of course, that's one type of this. If you know if you know the intent of others, how should you take that into consideration when you make your plans and so on? So yes, it's definitely important. Definitely something that touches upon work that's been done in this area of social AI. When it comes to the cultural part, I'm afraid I don't know, but I mean, it seems reasonable that it would be culturally dependent how we signal our intent. So you probably would need to kind of have more specific intent recognition depending on which cultural the people that you interact with comes from.
So, thank you very much, Fredrik. I think that you had the questions on very diverse subjects, and but it's normal because TAILOR is also working on very diverse matters. We'll stop the questions for now. I think that we have a lot in common between Confiance.ai and TAILOR. By the way, we organized a joint workshop together at the ACML PKDD conference a few weeks ago. And so, but you are more on the fundamental side, and we are really doing the applications, but we are looking at what the fundamental researchers do in order to be able to understand, use, develop, etc. So I think it would be very interesting to establish more concrete relations between ourselves, and we'll see how it goes in the future. At least with this talk that you gave, this can motivate a few people to start doing that. So thank you again.
Thank you, and looking forward to the further collaboration.